How many types of black holes are there? It sounds like a simple question, but if you search online, you will get completely different answers. Some sources say there are only 4 types of black holes. Other videos claim there are 11, 13 or even more. So who's right? Today we are going to investigate every major black hole category ever proposed. From black holes smaller than an atom to cosmic monsters so large they could swallow entire solar systems. And by the end of this video, you will know exactly which black holes are real, which are theoretical, and which ones could completely change our understanding of the universe. Let's find out. Before we begin, if you are wondering what a black hole is, how it forms, and what eventually happens to it, I have already made a complete video covering the entire life cycle of a black hole, from birth to death. You should see a card appearing in the top right corner of your screen right now. Feel free to check it out after this video. For now, let's focus on different types of black holes. Let's start with the 4 main categories of black holes described by NASA on its website. Let's start with the most common type. Imagine a star much bigger than our sun. According to NASA, when a star with more than about 8 times the sun's mass runs out of fuel, its core collapses and the star explodes in a supernova. What happens next depends on the star's mass. If it's near the lower limit, it may become a neutron star, but if the star had around 20 times the sun's mass or more, the collapse continues. Gravity crushes the core so much that a black hole forms. This creates a stellar black hole. Most stellar black holes contain between about 5 and 100 times the mass of our sun. Think about that, several suns squeezed into an object roughly the size of a city. Scientists have discovered many of them. Now let's talk about one of astronomy's biggest mysteries. Scientists found small black holes. Scientists found giant black holes. But where were the medium-sized ones? It was like finding ants and elephants, but nothing in between. These are called intermediate mass black holes. They are thought to contain hundreds of thousands of times the mass of the sun. Scientists think they should exist because black holes can merge and grow over time. Astronomers have found several strong candidates, so there is a strong evidence that intermediate mass black holes are real. Now we are entering monster territory. According to NASA, almost every large galaxy contains a supermassive black hole at its center, including our own Milky Way. The black hole at the center of our galaxy is called Sagittarius A star. It contains about 4 million times the mass of our sun. And that's actually small compared to some others. The black hole at the center of galaxy Holmberg 15A may contain around 40 billion suns worth of mass. 40 billion. Scientists still aren't completely sure how these giants formed, but they know they exist. In fact, nearly every galaxy we have studied seems to have one. Now things get strange. The first 3 black holes all come from stars. But primordial black holes may have formed before stars even existed. NASA explains that these black holes may have formed during the first second after the Big Bang. But then, the universe was incredibly hot and dense. Some regions may have become so dense that they collapsed directly into black holes. If they formed, some could have been smaller than a paperclip, others could have been larger than the sun. But there's a problem, no one has ever found one. So for now, they remain theoretical. So according to NASA, these are the 4 major black hole categories. But then why do some videos claim there are 11 or 13? Because the remaining black holes aren't always completely new families. Many are special versions of the black holes we have already discussed. And one of them may be made entirely from light. Let's continue. Ultramassive black holes are simply the largest members of the supermassive family. Some contain tens of billions of times the mass of the sun. They are basically supermassive black holes taken to the extreme. These appear to be real. A binary black hole system contains 2 black holes orbiting each other. Over time, they spiral inward and eventually collide. When they do, they create ripples in space-time called gravitational waves. Scientists have detected these waves here on Earth, so binary holes are definitely real. Imagine a black hole living next to a normal star. The black hole steals gas from the star. That gas becomes extremely hot and produces powerful X-rays. That's why they are called X-ray binaries. Astronomers have observed many of them. Now let's look at one of the brightest objects in the entire universe. A quasar is not actually a separate type of black hole. Instead, it's an extremely active supermassive black hole feeding on enormous amounts of gas and dust. As this material spirals inward, it forms a rapidly rotating accretion disk that becomes incredibly hot. The disk can emit so much energy that a quasar may outshine all the stars in its host galaxy combined. Some quasars can be seen from billions of light years away. One famous example is quasar 3C273. So while a quasar is not a separate black hole family, it represents one of the most powerful and energetic states a supermassive black hole can enter. Most black holes stay inside galaxies, but some wander through space alone. These are called rogue black holes. In 2022, astronomers using the Hubble Space Telescope found strong evidence for an isolated black hole wandering through the Milky Way. They detected it by watching its gravity bend the light from a background star. So rogue black holes appear to be real. Planck black holes are even smaller. They are among the tiniest black holes physicists can imagine. They exist mainly in mathematical theories. Scientists have never observed one, so they remain theoretical as well. Now for one of the strangest ideas ever proposed, a Kugelblitz is a black hole made entirely from energy. Not matter, not stars, just energy. According to Einstein's famous equation, mass and energy are related. So physicists wondered, what if enough light or energy were squeezed into a tiny space? Could it collapse into a black hole? For decades, many scientists thought the answer might be yes. But in 2024, researchers proposed a major challenge. They found that before enough energy could be concentrated to form a black hole, the energy would likely create particles that drain the energy away. If they are correct, a Kugelblitz may actually be impossible to create, which makes it one of the most fascinating unanswered questions in modern physics. Microblack holes are hypothetical black holes smaller than a grain of sand. Some theories suggest they could form under extreme conditions. Scientists have never found one. For now, they remain theoretical. Short for stupendously large astrophysical black hole. These hypothetical giants would be even larger than the biggest black holes we have discovered. No one has ever found one, but scientists have proposed the idea. For now, they remain theoretical. So who's right? The people who say there are 4 types of black holes, or the people who say there are 13? The answer is both. NASA's main classification includes 4 major categories, but when scientists include special categories, environments, and theoretical ideas, the list becomes much larger. Some black holes have been observed, some have strong evidence behind them, and some exist only in equations. But all of them remind us of one incredible fact: the universe is far stranger than we imagine. And despite everything we have learned, black holes remain one of the greatest mysteries in science. Who knows? The next type of black hole might be waiting to be discovered right now.